This is lesson 4.3 in your notes packet. We're starting on page 8 here, and we're going to cover page 8 and 9. Today's lesson is about two-step inequalities. So again, we're going to be following steps for solving inequalities, or solving equations, So we're still going to undo the addition or subtraction first, and then we will undo the multiplication or division, just like we've been doing all throughout. Only difference is when we multiply or divide by a negative, we need to remember to flip our inequality symbol. So in the first example, we're going to go ahead, drop our line down. The plus 11 is our addition or subtraction. So remember, we're trying to get G by itself. We're doing SADMEP, which is PEMDAS backwards. So I'm going to subtract the 11 on both sides. This leaves me with 4G is greater than 12. To get the G by itself, these are together by multiplication. I undo multiplication with division, so I'm dividing by 4 on both sides. G is greater than 3. On my number line, 3 is my target number, so I'm going to put one number to the left and one number up to the right. I'm going to go ahead and have an open circle on 3, and I'm going to shade to the right because G is greater than 3. In example number 2, I'm going to go ahead and add 10 to both sides in an effort to eliminate the 10 and get the B by itself. Less than or equal to, we get 45. Dividing through by 3 on both sides, we get B is less than or equal to 15. So 15 is our target number. One less, one more. Closed circle, and less than or equal to shades to the left. For example, number 3, I can go ahead and start to solve it this way, which is fine, or I can move the 30. So for this example, let's actually just solve it this way, and then we'll switch it out at the end. So we have the B divided by 5, and then we have this plus 27. So I'm going to subtract 27 on both sides. 30 minus 27 is 3. Greater than, those cancel, so I'm left with B divided by 5. To undo divide by 5, I times by 5. So those will cancel. B, symbol, 15. And then what I'm going to do is swap the B and the 15 here, opening to the 15, pointing to the B. So once I have my final answer like this, I can actually go ahead and graph it. 15 is my target, one above, one below. Open circle, B is less than 15, so I'm shading down to the left. In example number 4, I'm going to add 14 to both sides. Canceling out, 6x greater than or equal to, this will give me negative 36. I'm going to divide through by 6, x greater than or equal to a negative 6. So negative 6 is my target, 1 to the left, 1 to the right. We're going to put a closed circle on negative 6 and shade to the right because x is greater than or equal to negative 6. In example number 5 and 6, these are like what we saw as rule busters in the last chapter. So we're going to go ahead and put the top stuff in parentheses here. And we're going to go ahead and undo the divide by 3 with the times by 3. Doing that to both sides, the 3's cancel out. So we have x minus 4 less than or equal to 18. To get the x by itself, we have to add 4 to eliminate this from that side. X is less than or equal to 22. I'm going to have 21, 22, and 23. I'm going to close up my circle on 22 and shade to the left. In example number 6, again, I have stuff up on the top, so I'm going to put it in parentheses. Stuff divided by 8. To undo divide by 8, I times by 8. Doing that to both sides. Timesing by 8, dividing by 8 cancel. Bringing down the x plus 12 greater than 1 times 8 is 8. And to get the x by itself, I need to subtract my 12. So I'm going to get x is greater than negative 4. So we have a negative 4, one number less, one number more. Open circle, and greater than shades to the right. Circle the possible values that satisfy the inequality. So we're on page 9 here. We're going to go ahead and solve these. So we're going to subtract 6 from both sides. That leaves me with x over 5 is less than a negative 4. I'm going to times by 5 to undo the division. So x is less than negative 20. Only number less than negative 20 is negative 21 on this list. Here we can go ahead and solve it this way, or we could move the 7. It would really be up to you. I'm going to go ahead and move it in this case just because I'm kind of lacking on space anyway. So I'm going to go ahead and subtract the 4. So I have 3x, because those cancel, is less than or equal to 3. Dividing through by 3 on both sides, I get x is less than or equal to 1. And I covered this up. So this was a negative 1 here, it looks like. So that would be less than or equal to 1. And 1 would be less than or equal to 1. Example number 3, I'm going to subtract my 1 on both sides. So I have 7x is less than or equal to 14. I'm going to divide through by 7. So x is less than or equal to 2. That would include negative 2 and 1, as well as number 2. Two-step inequality word problems. So similar to what we saw with equations, we're going to have one number on here that's going to happen once, one number that's going to happen more than once and get our x, and then we're also going to have what we used to call our equals number, but we'll have kind of what is our total number more than anything will be on the other side of our inequality sign. We'll also be looking now for keywords, though, that are going to signal to us which inequality that we have to use here. So the first example, Daniel had $25 to spend at the fair. It cost $4 to enter and then $1.50 for every ride. How many rides could Daniel go on? So the $4 happens once, and he had to pay for rides. So $1.50 for every ride. We don't know how many rides he's going to go on. So we're going to call that X. So as of right now, we have 4 plus $1.50 X. The other number here is this $25. So that's his total number. Can Daniel spend more than $25 or can he only spend less than $25? It's kind of the first thing that we have to figure out. If he only has 25, he can't spend more, so we would have to put less than. But since he actually does have 25 with him, it could be equal to the 25, so we'll include that right there. So 4 plus $1.50x is less than or equal to 25. So we're going to go ahead and subtract the 4 on both sides because we're going to figure out x, how many rides he can actually ride. So $1.50x is less than or equal to 21. And then we're going to go ahead and divide through by $1.50. And we get x is less than or equal to, that's going to give us 14. So Daniel can go on 14 or less rides, or we could say 14 or fewer rides or anything along those lines, but we need to put some words to it. We're not just going to leave our inequality symbol here. For the next one, the 7th grade class decided to put on a talent show to raise money for Dance Marathon. They will have to pay $250 to rent the auditorium. They are hoping to charge $7 per ticket, and they want to make at least $800. This kind of signals to me that this is our equals number, and we want to make at least 800. So we really want to go over 800, but we want to be at that point. So we want to be greater than or equal to 800. So we have to figure out now, we have the $7 per ticket and they have to pay to rent the auditorium. So if they charge $7 per ticket, figuring out the price of the tickets would be 7 times X is how much money we would bring in. But if they have to pay to rent the auditorium, that's going to come out of what profit they're actually making here. So we're going to go ahead and subtract $250 from both sides in this one. So I'm going to go ahead and add the $250 here. Those will cancel out. So I'm going to get 7x is greater than or equal to 1,050. And then I need to go ahead and divide through by 7. So 1,050 divided by 7 is going to give me 150. So how many tickets do they need to sell? We're trying to figure out their $7 a ticket. X is greater than or equal to 150 tickets. So we need to sell at least 150 tickets in order to make our money here that we're looking to actually make, the $800. If we sold over 150, we'd be happy. If we sold under, we wouldn't meet that number of 800 that we were trying to raise. For the last example here, Sam had $450 in a savings account at the start of the summer. The plan is to have at least $200 left at the end of the summer. If $25 gets taken out weekly for food and clothes, how many weeks can Sam withdraw money? So we're taking this out, which tells me that we're subtracting 25. And we're going to do this every single week. So we're starting at $450, taking out $25 every week, and we want to have at least 200. So that means $200 or more. So we're going with greater than or equal to here. So we're going to go ahead and subtract our $450 on both sides. bring down our negative 25x is greater than or equal to, we get negative 250. We're going to divide by negative 25. And if that's kind of giving you a signal, ooh, we need to flip our inequality, you are correct. So x is less than or equal to 10. So in order for him to have at least $200 left, how many weeks can he withdraw money? So 10 or fewer weeks, because x is less than or equal to 10. And that's it for lesson 4.2 then, solving two-step inequalities.